Yes, good evening. Last class electricity we discussed. In electricity we discussed about what is electricity, electric current, electric potential, then resistance, Ohm's law, then resistance depends upon, yes, and resistance, series and parallel. So these chapters we have studied, and each and every subchapter, we identified the numericals, and further going today these questions we will see. Yes, resistance, series and parallel we have studied, and the numericals we did it. Next, heating effect of electric current. So this is one of very important chapter and very easy to analyze. So based on that, the CBSE board is asking questions. Then we will see what kind of questions, and after this we are going to learn about what CBSE question paper asking the questions related to electricity. That questions we are studying today. Now, heating effect of electric current. So generally from the electricity we are getting heat energy. So what kind of appliances we are using? Electrical heater, toaster, yes, iron box, geyser, heat oven, hair dryer, and many other applications we are using. So, how that machine know that how much heat energy we want it? Let's say a simple example, iron box. If you want to ironing, yes, we have different types of clothes. So on the iron box there is a knob which is indicating different kinds of clothes. So each cloth, how much heat energy required, we already pre-designed. So how to calculate heat energy? That is the most important activity now. Let's say, take an iron box. This iron box, from this iron box we need heat energy. How to get the heat energy? We need to connect it to power supply. Once if you give the power supply, automatically heat energy will be created after some time. Yes or no? Then we are ironing. So how much heat energy which is creating? That we are learning now. We are giving power. What is power in physics? Power P is equal to work done in unit time. So who is doing work? Electric charges in the form of electric potential. So V is equal to W by Q, which implies W is equal to V into Q. Substitute over here. So power P is equal to V into Q by T. Alright. So what is charge? As you know, Q by T we can call it as electric current I. I is equal to Q by T. We know that. So on the place of Q by T, you can substitute V into I. So power P is equal to V into I. We got power P. So each and every electrical appliances has to obey the Ohm's law. So as per Ohm's law, V is equal to IR. Substitute Ohm's law over here. So power P is equal to IR into I. So IR into I how much? I square R. So I square into R. Clear? Now power P we got it. Finally what we need it? Heat energy we want. Heat energy when we can get? We need to give power. It will take some time. So H is equal to P into T. So H is equal to power P how much? I square R into T. So this is the way H is equal to I square RT we derived. Repeating. Iron box we given power. Power P is equal to work done in unit time. So who is doing work? In the form of charged particles, in the form of potential, we are doing work. So V is equal to W by Q. W is equal to V into Q. We can substitute over here. V into Q by T. So as per electricity, electric current, I is equal to flow of charged particles in unit time. So as I is equal to Q by T you can substitute over here as I. So power P is equal to V into I. According to Ohm's law, V is equal to IR. Substitute IR over here. Okay. So IR into I, we can write I square R. That is power P. And we need heat energy finally from electricity. So heat energy we will get. We need to give power. It will take some time T. Alright. So H is equal to P into T. And on the place of P, I square R we have substituted. So H is equal to I square RT is the heating effect or Joule heating effect. So these words they'll ask in CBSE. Hope you understood this. Now, different appliances need different current for their working. It is impracticable to connect all of them in series, since that will pass the same current through all. Also, if one appliance's in series combination fails, whole circuit is opened. Whereas in parallel combination, the current is distributed as per the requirement and every appliances works independent of the other. In house wiring, These appliances are hence connected in parallel. So these are all the practical appliances of heat energy. We will see some of the questions how they will ask. There is a question over here. 100 joules of heat are produced each second in a 4 ohms resistance. Find the potential difference across the resistor. Option A 10 volt, option B 20 volt, option C 30 volt, option D 40 volt. Repeating, 100 joules of heat are produced each second in a 4 ohms resistance. Find the potential difference across each resistor. Now, always we need to follow given data, required data formula. So given data they have given H is equal to 100 joules each second. Time t is equal to 1 second. Resistance 4 ohms. So find the potential energy. V is equal to how much? So as H is equal to I square R into T. We know that. But I value that didn't give. We need I value to find out V over here. They are asking V. Okay. As you know that V is equal to I into R. V is equal to I into R. So we know R value, but we don't know I value. So from this given data, calculate I value. So I square is equal to H by RT. So H value how much? 100 by 4 into 1, which is 4. 100 by 4, which is 25. So I square is equal to 25. I is equal to 5 amperes. Now what they're asking from us? Electric potential difference. So V is equal to I value 5 into R value 4, which is 20 volts is the right answer. So exactly we can get the answer if we follow the proper method. Next question. An electric bulb is connected to 220 volts generator. The current is 0.5 amperes. What is the power of the bulb? This question, how to solve this? Yeah, always given data, required data and formula. V is equal to, they have given 220 volts generator. Current I is equal to 0.5 amperes. So what is power they are asking? So while derivation of H is equal to I square RT, somewhere we got that equation P is equal to V into I. Hope you remember this. So directly we can apply that 220 into 0.5. Okay, 110 watts of power we will get it. So which option? Option A 120 volt, 110 volts. Option B 55 watt, 40 watt and 220 watt. So we get that option A 110 watt. An electric refrigerator rated 400 watt operates 8 hours per day. What is the cost of energy to operate it 30 days at 3 rupees per kilowatt hour? Okay. An electric refrigerator rated 400 watt. So power P is equal to 400 watt. Operates 8 hours per day. Let's say that is time T. 8 hours. Let it be in hours. Suddenly don't convert into seconds, especially in this question. Okay. Now What they're asking? Cost of energy. Finally, we need to find out energy. H value how much? For 30 days. Yes, time 8 hours per 30 days. Totally 240 hours. Let it be like this. Now, as you know, H is equal to P into T. P value how much? 400 watt. Time 240 hours. So finally, how many watt hours? We will see that. 96123 watt hours. So 96,000 watt hours, we can write it as a 96 kilowatt hours. Yes, 96 kilowatt hours. So this is the total energy what we consumed. But each kilowatt hour, why we converted into kilowatt hours? Because in that question they asked kilowatt hours per 3 rupees per kilowatt hour. So finally we consumed up to 96 kilowatt hours into 3. Okay. You will get the 288 rupees to enter the consumption. So this is the way electricity bill will be generated every month. Yes. So these are all the topics what we are learning from electricity. Now we can see that how the CBSE questions will ask from these chapters. Yeah. Hope students are noticing that what kind of questions now, which is most important day to day. And children are studying very good, very hard, but what kind of questions, how to write the answers is the major challenge. We will practice it now. Practicing questions, how they're asking in class 10th standard. There is a question over here. Two resistors of 20 ohms and 40 ohms are connected in parallel in an electric circuit. How does the current passing through the two resistors compare? There is a question. Two resistors of 20 ohms and 40 ohms are connected in parallel in an electric circuit. So while reading this question, children's mind will go through calculate the total resultant resistance in parallel. Don't do that. How does the current passing through the two resistors compare? This they are asking. They didn't ask any total resultant resistance. Most of the times I noticed the children are directly connecting that total resultant resistance in parallel. Don't do that at all. Read the question completely. How does the current passing through the two resistors compare? So we need to calculate electric current. Now immediately thought will be generated. What about electric potential? That is one of a question now. We will answer this. Now the two resistors, let's say R1 and R2. Yes, R1 and R2 are the two resistors. R1 value is 20 ohms. R2 value 40 ohms. Clear? Now they connected in parallel. But electric potential is same, right, in parallel? V value is same. This logic we are forgetting. Potential will be the same if it is in parallel. We no need to think why they are not given. So as you know that they are asking I1, I2 values how much? Yes. Through the two resistors, how that the current value? As you know, V is equal to I into R. I is equal to V by R. So V value is constant, let it be. We can write I1 is equal to V by R1. I2 is equal to V by R2. So I1 by I2, we can write V by R1 by V by R2. That is equal to R2 by R1. So they are asking about the current through the two resistors of R1, R2, we need to find out I1, I2 values across R1 and R2 how much. So they given the values of R2, that is 40 ohms, and R1 is 20 ohms. So we will get that 2:1. So I1 is to I2, the ratios are 2:1 is the answer. So this is the way the 2 marks question we need to write. Next question. Yes, almost similar kind of. Why V is the same? This is the question asking to the student. Here I'll make it clear. When R1, R2 resistors which is in parallel, once we can recollect this, let's say R1 and R2 are the two resistors we connected in parallel. Parallel combination, we know that all one ends at one terminal, all other ends at other terminal. So these two terminals we connected to battery. Once we connected to battery, for example, this wire disconnected. Now the same battery connected to R1 resistor, current will be flow. It's a closed circuit. Now this connected, this we disconnected. Now the same charged particles will go through R2 resistor. So finally R1, R2 both resistors, once if it is in parallel, we given the common potential. V is the same. That is the reason as the student asked, V will be the same which is in parallel connection. If it is in series connection, what happened? Here current will be the same, but potential will be V1 and V2. Okay. So that is the reason V will be the same. Hope my answer is satisfying your question. Now coming to the second question. Again the same kind of question, but values are different now. Probably the student can able to guess very easily. R1 by R2, I1 by I2 is equal to R2 by R1. Before formula what we derived, which is 60 by 30. Again 2:1 is the answer. Fine. Next. Define electric circuit. Distinguish between open and closed circuit. So what is electric circuit? How to define electric circuit? The combination of source, indicator and connectors. This is called it as electric circuit, as simple. The combination of source, indicator and connectors. This is simple circuit or electric circuit. Define open circuit and closed circuit. When that will be open circuit? The open-ended of, in the class we have discussed. In the open-ended of source, indicator and connectors, we can call it as open circuit. The closed end of indicator, source and connectors, we can call it as closed circuit. So this is the way we need to write this for 2 marks question. What is the lowest resistance that can be obtained by combining of 4 coils of resistance? 4 ohms, 8 ohms, 12 ohms and 24 ohms. So this is one of a CBSE question. One of a examination they have asked. So how to answer this question? What is the lowest resistance that can be obtained by combining of 4 coils? They given some values. So the students, we need to understand the lowest resistance when it comes if all the resistance which is in parallel combination. Yes. So all one ends at one terminal, all the other ends at other terminal. While we explaining this resistors in series, we have discussed the total resultant resistance is always lesser than individual resistances. Hope you understood this theory. So whenever we are saying we will get the minimum value, the question they are asking about the lowest resistance other than asking parallel combination. So once the question appears lowest resistance, all the resistors you combine in parallel. So R1 is equal to 4 ohms, R2 is equal to, yeah, just a minute. Yes, sorry. R1 is equal to 4 ohms, R2 is equal to 8 ohms, R3 is equal to 12 ohms, and R4 is equal to 24 ohms. So these four resistors connect in parallel. 1 by Rp is equal to 1 by 4 plus 1 by 8 plus 1 by 12 plus 1 by 24. So all the LCM will be 24. 6 plus 3 plus 2 plus 1. 12 by 24, which is 1 by 2. So 1 by Rp is equal to 1 by 2. They're asking lowest resistance Rp is equal to 2 ohms. So this 2 ohms is the lowest resistance. What they're expecting in the question. Next question. Write the mathematical expression for Joule law of heating. Name one device which works in this principle. This is again the question by the CBSE. Write a mathematical expression for Joule law of heating. So just we have studied that. H is equal to I square RT. H is equal to I square RT. This is mathematical expression. And the name of the device, let's say the devices are iron box, heat oven, geysers. So these are all the devices names we can able to write it. Next. Yeah. What happens to the resistance of a conductor when the length of a conductor is reduced to half? Repeating the question again. What happens to the resistance of a conductor when the length of the conductor is reduced to half? So how to answer this question? As you know that length and resistance R is directly proportional to L. Now the length of a conductor is reduced to half. So L becomes L by 2. What happens? R becomes R by 2. Very simple. So we can write this is the way. Next question. Define SI unit of resistance. They're asking define SI unit of resistance. So here the students has to understand, we need to define what are the units of SI units of resistance. So some children's they wrote as just ohms, but they not defined ohm. The question here defined 1 ohm. This is the question actually. Now how to answer this? As you know that according to Ohm's law, V is equal to I into R. From that, R is equal to V by I. Resistance units ohms, electric potential units volt, electric current units amperes. So define 1 ohm, which means 1 volt by 1 ampere. That is the define SI units of resistance. Okay. Next. What happens to the resistance of a conductor when temperature is increased? This is also we studied in theory. Once temperature increases, resistance will be increase. Conductance will be decrease. So hope you remember in that class last 2 days back, once we started this electricity chapter, we explained about summer holidays, like generally summer days, why the power cut is very more in village area. So this is the question we discussed. Length increases, resistance will be increased due to the temperature. So temperature increases, resistance also will be increase. Next, what is electrical resistivity? In a series electrical circuit comprising a resistor made up of a metallic wire, the ammeter reads 5 amperes. The reading of the ammeter decreases to off when the length of the wire is doubled. Why? So this question asked by CBSE in one of the year. So how to write this answer? What is electrical resistivity? Resistivity, generally the symbol rho, what we can able to remember. So R is equal to rho into L by A. The resistivity rho is equal to RA by L. Okay. Next combining question over here. In a series, the electrical circuit comprising the resistor made up of a metallic wire. The ammeter reads 5 ampere. Now the metallic wire, through that we given power in a series electrical circuit. Ammeter reading comes to 5 amperes. Now the reading of ammeter decreases off. In the next case, it decreases off when the length of the wire is doubled. Now length and electric current relation we need to find out. R is directly proportional to L. Okay. Now the length is doubled. What about the resistance? Also will be double. Once resistance will be double, what about electric current? Resistance means opposition of flow of charged particles. Current will be reduced to off. Yes. So why it is? We need to say the reason. The resistance will be double if length of a conductor is doubled, so current will be reduced to off. That's the reason ammeter is showing off of the reading. Clear? Next question. Now this is the most important question. What is the minimum resistance which can be made using the resistors each of 1/5 ohms? What is the minimum resistance which can be made using 5 resistors in each of 1/5 ohm? Now each resistance value 1/5 ohms. Like that, how many resistors are there? 5 resistors. Again, R2 value also 1/5 ohms. R3 1/5 ohms. R4 1/5 ohms. R5, 5 resistors of each of the resistance is 1/5. What given the question? What is minimum resistance? So before we discussed the minimum resistance means we need to connect in parallel, is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4 plus 1 by R5. The students and audience, we need to be very careful to teach this topic to the student. Why? Because many times I have noticed they given the directly 1/5 value other than 1 by R value. So while writing on the board, we need to be careful that the student has to put the values of each resistance. So 1 by Rp is equal to 1 by R1 value how much? 1 by 5. Again R2 value 1 by 5. 1 by 5 plus 1 by 5 plus 1 by 5. Now 1 by 1 by 5 is equal to 5. 5 times 5. This step students can able to understand easily. They know this well aware. But 1 by R value, I noticed they given directly 1 by 5 value. 1 by R value. So we need to be focused much on R1 value presentation. So 1 by Rp value, that is 25. So 1 by Rp value 25, Rp value how much? 1 by 25, which means 0.04 ohms. That is the minimum resistance. While using that, each of 1 by 5 ohm we can able to get through. Hope you satisfied this answer. Yes. Next question. You have all two metallic wires of resistance 6 ohms and 3 ohms. How will you connect these wires to get effective resistance of 2 ohms? This is one of a question. So 6 ohms and 3 ohms, we need to get 2 ohms. They are asking how to connect these two resistors. So the children has to understand that the resistance which is in series and parallel. While in series what happened? While in parallel what happens? In series connection, the total combination of resistance will be maximum. We will get the maximum resistance. In parallel connection, we will get minimum resistance. While in the question itself there is an answer. So 6 ohms and 3 ohms, how to connect it to get 2 ohms? As you know, 2 ohms is lesser than 6 ohms and 3 ohms. So obviously we need to connect in parallel. But how to write the answer now? The first statement, in parallel combination, the total resultant resistance is always minimum than individual resistances. So this step we have to make it clear. Then formula, 1 by Rp is equal to 1 by R1 plus 1 by R2. They have given that 1 by 6 ohms and 1 by 3 ohms. So the 6 ohms is LCM, 1 plus 2, which is 3 by 6 is equal to 1 by 2. So 1 by Rp is equal to 1 by 2. So Rp is equal to 2 ohms. So this method, if you follow that, exactly you will get the 2 marks. Or 2 marks or 3 marks question or whatever. Clear? Next question. Yeah. This is the most frequently what I noticed this question. Generally 2 marks question they'll ask you. Draw the schematic diagram of circuit consisting of a cell of 1.5 volt, 10 volt resistance and 15 ohms resistance and a plug key all connected in series. So probably this is 2 marks question and 5 marks ABCD they may ask any one of the area. So how to do this? Just they're asking about schematic diagram. Open circuit, closed circuit, simple circuit we noticed. The cell of 1.5 volt. They asked the cell or battery. This is the most important. Sometimes they'll ask battery of 4 cells kind of thing. We need to understand the symbols of cell and battery while in the starting. So that you need to represent. Cell refers long lead and short lead. Long lead positive, short lead negative, that is 1.5 volts. So this we connected to a plug key. Let's say this is closed switch. Okay, mention over here plug key. Then they're not asked about any other ammeter, voltmeter, nothing. So we can escape it. We need to connect it to 10 ohms resistance. Then all are in series they asked. Again 15 ohms resistance. Combine it. Close it. So that's it. Okay. You will get that full marks. Next. The voltage current graph of a metallic circuit at two different temperatures T1 and T2 is shown. Which of the two temperatures is higher and why? This is the question. Voltage current graph of a metallic circuit at two different temperatures T1 and T2. Which of the two temperatures is higher? So you can see that T1 and T2 here, let's say, uh, yeah, I can choose black color. On the graph, T1 is the more potential. Okay, this is I current. This is T2 are the less potential difference over here. IT value more. As you know that R is equal to V by I. So where the potential is very more? T1 is the potential is very more. So once T1 is increases, temperature increases, resistance also will be increase. Clear? Next question. Next question. What is meant by saying the potential difference between 2 points is 1 volt? Now, this is the direct question. Define electric potential or define 1 volt. How to define electric potential? As you know that electric potential will be defined as work done by charged particle is called as electric potential. Electric potential units are volts. Work done units, joules. Charge units, coulombs. Okay. Define 1 volt. 1 joule by 1 coulomb. That's the question now. Define 1 volt. 1 joule by 1 coulomb. So how to write the answer? 1 joule of work done. 1 joule of work done by 1 coulomb of charged particle. Charged particle is called as 1 volt. That's it. Next. This is one of the most important and periodically asking question. Every year somehow we are getting this question. In an experiment to study the relation between the potential difference across resistor and the current through it, a student recorded the following observations. So R and I values they have given. On examining the above observation, the teacher asked the student to reject one setup of readings as the values were out of agreement with the rest. Which one of the above sets of reading can be rejected? Calculate the mean values of resistance of the resistor based on the remaining 4 sets of reading. So how to answer this question? So as you know, R is equal to V by I. R is equal to V by I. We need to find out the resistance because here there are the 5 students, they completed their Ohm's law experiment, they got their records. We need to find out which one is the odd one that we can remove out. So remaining values of resistance, we can see the mean value. Yes. Now the first student potential is 1 and electric current is 0.1, which is 10 ohms. We got it. For second student, R2 is equal to 2.2 by 0.2. Approximately that is 11 ohms. We got it. R3 student, electric potential 3 and electric current will be 6. So this comes approximately 5 ohms. We got it. R4 is equal to 4 by 0.4, which means approximately 10 ohms, and R5 is equal to 6.4 by 6, approximately 10 ohms. So all got 10, 11 approximately, but R3 value quite different. So this student, what he performed, is absolutely wrong. So we can neglect it. Now calculate the mean value of resistance they are asking. So mean value in the sense of R1 plus R2 plus R4 plus R5 by 4, because R3 is neglected. So 10 plus 11 plus 10 plus 10 by 4, approximately 10 ohms of the mean resistance we will get it. Hope you understood clearly what electricity chapter and what kind of CBSE questions they will ask us and how to answer these questions. Thank you so much, students and teachers and audience who are all the physics lovers entire the globe. Every day 10 to 11 p.m. I committed to teach as the outreach programs in physics. So if you have any question, in my description there is an email ID. You can send email to me. I'll answer your questions. Thank you so much for attending this session. You can see entire the channel what we promised, and it goes through. Thank you so much. Good night. Bye for the day. Jai Hind.